Okay, so let's continue with a few more similar examples to the ones that we've been dealing with. This time, the factoring is a little bit more difficult for the following reason. Let's look at our first example. We're going to factor by the grouping method, and if we look at pairs of terms, we see that some of the signs now have changed around it. How do we handle that situation? So let's go through the situation right here with our first pair of terms, and I'm going to just underline pairs of terms here. If I look at my first pair of terms, I've got 5xy minus 9y, and I recognize that y is the only common factor among those two. So I'd have to say y times 5x will give me 5xy, and y times minus 9 will give me that common factor. Now I look at my second pair. 18 and 10, yeah, those share a common factor of 2. But notice that one thing that's happened right here is that I've got a subtraction sign between those. When I see that, I have to think to myself, well, what would I have to multiply by negative 2 to get negative 18? And that has to be positive 9. Negative 2 times positive 9 gives me negative 18. Negative 2 times something gives me plus 10x. Well, the only thing that could be is negative 5x. Well, now that seems kind of weird. Why would I have that negative right there? Sometimes the way the terms are arranged makes a difference. Certainly 5x minus 9 is not the same as 9 minus 5x, but you might suspect that somehow taking this negative into account could change things. So let's rewrite this. In this case, we can rearrange some of the terms to make it a little bit easier on us. We would see that 5xy minus 9y plus 10x minus 18 will give me a similar thing to what I was talking about before. That is, if I factor out y, I'm going to get 5x minus 9. But from the second pair, if I factor out plus, keep the sign in between these pairs, 2 times 5x would give me 10x. And 2 times minus 9 would give me minus 18. And so 5x minus 9 becomes our common factor. We'll have 5x minus 9 times the quantity y plus 2. Okay, well, let's try another one here. This might be interesting. It looks like we've got some higher power terms, but is it really a big deal? No, probably not. Let's see. What's the common factor among y to the fifth and 5y cubed? Well, that has to be y to the third. So y to the third times something gives me y to the fifth. Well, yeah, sure enough, that's y squared. And y to the third times minus 5 is going to give me 5y cubed. Well, now what? How about this next pair? I'm going to keep the plus sign between, but I'm going to factor out 4. I've got 4 times the quantity y squared, and 4 times 5 again gives me 20. So that gives me an interesting factor. This time I've got y squared minus 5, but it doesn't matter what the power is. The same property still holds. We will have y squared minus 5 times the quantity y cubed plus 4. And that is our fully factored form of this trinomial. All right, one last one right here. Let's take a look at this. We've got 2y cubed minus 2y squared minus 3y plus 3. Okay, this one we might have some trouble with the signs. Let's see what happens, though. All right, what's common among these two terms? That's right, 2y squared. So we've got 2y squared times something gives me 2y cubed. Well, the answer is y. 2y squared times what gives me 2y squared? Well, the answer is 1, but we need to make sure it's y minus 1. Now, it's not as though we can just factor out 3 here and ignore the signs of these last two. We're going to have some trouble. But what could we factor out? Well, if it helps, sometimes it pays to picture those last pair of terms as an addition of a negative. So we've got 2y cubed minus 2y squared. So far, so good. We've already factored that part. Plus, we can think this is negative 3y plus 3. we squeezed out a y minus 1 from this first pair of terms, so we might ask ourselves, well, what do we have to squeeze out from this second pair of terms to get y minus 1? And the answer, of course, is that we have to take negative 3 times y to get minus 3y, and negative 3 times minus 1 to get plus 3. So keeping that idea of two terms from the last pair the same, that gives us this idea that y minus 1 now is our common factor. So we'll take it out, factor it out, and it's going to leave us the quantity 2y squared minus 3 as our result. Okay, good luck with your assignments. I'll see you in class.